What's up, Mustangs? Miss Titus here, and today we're going to talk about finite differences K. So you already have this in your iPod. What we're going to do first is look at what they want us to find. It says here, find the value of the 36th term and the rule. Okay, so we've done this before. This is just a little more complicated because we're going to have some fractions and decimals, but don't be worried. As always, the first thing that we want to do is find our delta y and our delta x, because that's going to tell us what our coefficient is. So if I look at my y values, I have 1.5, 2.5, 3.5, 4.5, and 5.5. Each time, they're increasing by 1. Okay? And then I'm going to look at my x terms. I have 3, 6, 9, 12, 15. Each time here, I can see the pattern is that x is increasing by 3. So over here in this column, I'm going to write the ratio of delta y over delta x, which is 1 to 3. And I can't reduce or simplify, so that just simply means that my coefficient is 1/3. So remember that delta y over delta x is also your m. So whenever I see m, I'm going to write 1/3 in my process column. And then I'm going to go in and fill in my x values. Here x is 3, x is 6, x is 9, x is 12, x is 15, x is 36. Okay, and then I need to find my constant. So to find my constant, I need to multiply my coefficient and my x value, and then ask myself, what do I need in order to get the output that's given? So if we just scoot up real quick here, I'm going to do 1/3 times 3, and I get 1. But I don't need 1, I need 1.5, so I need to find the difference of those two. 1.5 minus 1 is 0.5. That means that I would have to add 0.5. But I'm not going to write 0.5. I'm going to change that to a fraction, and I'm going to write 1/2. Okay, so my coefficient is 1/3, my constant is 1/2. So each time I add 1/2. Let's see if that works for 15. We'll do 1/3 times 15 plus 1/2. And I get 5.5, and that's what my output is here, 5.5, so that I know I'm right. So in order to find the 36th term, I'm going to do 1/3 times 36, and then add 1/2. And I get 12.5. And let's go over here and make sure that that delta y over delta x is the same. So from 15 to 36, let's see, 36 minus 15 is 21. From 12.5 to 5.5, is 7. So my delta y over delta x would be 7 over 21, which would simplify to 1 over 3. Okay, so now I have my rule. So let's go ahead and fill out both of our tables. Remember that this table is just the horizontal version of this table. X is always x. It goes on top, it goes on the left. 3, 6, 9, 12, 15, 36. 3, 6, 9, 12, 15, 36. And then I have 1.5, 2.5, 3.5, 4.5, 5.5, and 12.5. Okay, so our rule is what we got here in our last process column, 1/3 x plus 1/2. My equation is the same thing except for it's going to have y equals 1/3 x plus 1/2. The constant is the number added or subtracted to the end of the rule, so that's going to be 1/2. The coefficient is the number in front of x, or my delta y over delta x, which we said was 1/3. And then if we're going to write it out in words, we're going to say the ordinate is 1/2 more than 1/3 the abscissa. Okay, and then if we come over here and we graph our points, and label my axes, I'm going to create my scale. Okay, and then I'm just going to plot my points. I have 3, 1.5. I have 6, 2.5. 9, 3.5. And then I have 12, 4.5. Alright, and that's all we have for finite differences K. Same rules apply even when there's a fraction involved. If you have any questions, go ahead and put them in the form below. And as always, staying strong.